Okay, so if I look at 12.1 and we're looking at limits, this right here is the definitional limit, which basically says as x approaches any constant value, your function will approach a different value. Okay, and there's lots of different ways to look at limits. The first way we're going to look at limits is by graphing. So we're going to graph 3x minus 2, and we're going to find the limit as x approaches 2. Okay, so I'll go ahead and graph 3x minus 2 into your graphing calculator. Okay, and then you should get this line. And then if we want to know what our value is as x approaches 2, if I go over to 2 on my x-axis, I look and see where my y value is at that time.
Also, you can use our table.
You can use your table, yep. Or you can use your trace function, which is right next to your graph button. If you hit trace and then type in 2, it'll take you right to where x equals 2. And so 4 then is your answer. Where's your limit? 4. Yep, so your limit as x approaches 2 of 3x minus 2 equals 4. Okay, so we'll do the same thing for this function. The limit as x approaches 0 of x divided by the square root of x plus 1 minus 1. And make sure you put everything in the denominator in parentheses, otherwise your graph won't come out right.
Zero.
Yep. There's nothing for your y, right? Because 0 is undefined, so then go to your table. Okay, and so like I told you, you could use your trace function. If we type in x equals 0, it gives us a blank for y. And what that tells us is that our graph is undefined at y. But we can still find our limit by going to our table. So second graph takes you to your table and look at the values around 0 to figure out which one they're approaching. So I know that I go from 1 to 2.42, so I'm going to guess that my limit would be somewhere around 2, because 2 is in between 1 and 2.41. Okay, and so if I go back to my graph, I can see that at 0 I am right, basically at 2. So sometimes you'll have to estimate your limits. Okay, then one of the other ways that we can find limits is by using direct substitution. 2. Okay, and so if I'm given the limit as x approaches 4 of x squared, if I'm going to do that using direct substitution, then I'm going to plug in 4x in my equation. And so doing so, then that gives me 4 squared. And 4 squared is 16. So my limit would be 16.
So it's just like what it's talking about.
You can do it that way on all of them, except for this one where it was undefined. So if I do the same thing then for the limit as x approaches 4 of 5x, I plug in 4 for x. I get 5 times 4, and 5 times 4 is 20. Okay, direct substitution is probably the easiest thing to use, except when you get undefined values, which happens every once in a while. And then lastly, the limit as x approaches 9 of the square root of x. If I plug in 9 for x, I get the square root of 9, which is 3, positive or negative 3. Okay, pretty straightforward. Limits are pretty easy. 859, 13 to 26, 49 through 68.